In this example, we're asked to find what is the displacement if we have a known strain field. So if we know, so in this example problem, we have a rod that is fixed at point A. Okay, so that means there's no displacement at point A. Okay, so we can say that U at point A, if x is equal to 0 at point A, would be equal to 0. Okay, so what we're asked to do is we're given the strain as a function of x. We wanted to know what is the displacement at point B. Okay, so we know that epsilon x is equal to the partial derivative of u with respect to x. And we also know it's equal to k, which is a material constant, times L minus x. Okay, where L is the length of the rod. Okay, um, so since this is given to us as a partial derivative, but since this is only a function of x, we can really write it as a normal derivative or a single variable derivative. So we're going to name it just du dx. All right. So then we can, so since it's a simple derivative, we can then integrate it. So we can say u of x would be equal to the integral of k L minus x dx. All right. So if we do that, what we end up getting is we get k Lx minus k x squared over 2 plus some constant. All right. So let's plug, so to determine what our constant is, let's determine, let's plug in our boundary condition here. All right. The rod is fixed at point A, so there'll be no displacement. So we can say that u of 0 is equal to 0 would be equal to KL times 0 minus K times 0 squared over 2 plus C. Therefore, C would be equal to 0. All right, so you could say that u of x would be equal to KLX minus KX squared divided by 2. All right, and then the last part of the problem asks us to, what is the displacement at point B? So point B is at x is equal to L. So we can plug in u of L is going to be equal to k L times L minus k over 2 times L squared. What we end up just getting in this case is KL squared minus KL squared divided by 2, or it's going to be equal to k over 2 times L squared. Okay. All right, so that's our answer, and that concludes our problem. So for a 1D system, if we're given the strain as a function of a variable, we just have to do a simple integral and plug in the boundary condition to solve for the integration constant. Once we have that, we can solve for the displacement or the displacement at any point along the rod.